Let's take a look at some interesting problems. This first one says the amount of force needed to keep a stationary object on a flat surface from moving is called static friction. If a book weighs p pounds and is on a flat surface that is at an angle of theta degrees, the coefficient of static friction C for the book given by C times P times cosine of theta equals P times sine of theta. Solve the equation for C and find the value of C when theta equals 15 degrees. Now, this entire problem right here seems daunting because there's just a lot going on. When it comes to a problem like this, we have to take a step back and we have to realize that we know what we're doing. We're not idiots. We can take some realistic steps and see where it goes. Like, just start going and doing some things that are real and truthful. So right here, we have CP cosine of theta equals P sine of theta. Now, the first thing it says is solve the equation for C. We know how to solve equations. We've been doing that for years. To solve for C, we would have to divide both sides by P cosine of theta. The P and cosine of theta cancel out over here, leaving us with C. Over here, the P's also cancel out. And we're left with sine of theta over cosine of theta. What is sine of theta over cosine of theta? It is tangent of theta. So C equals tangent of theta. We solved the equation for C and find the value of C when theta is 15 degrees. So we want to know what is C when we put in a 15 degrees for tangent. We need to evaluate tangent of 15 degrees. That's what this problem really comes down to. Tangent of 15 degrees, we could find that one of a few ways. We could find it using a sum or difference identity. I'm going to choose to do it with a half angle identity. I know that C is equal to tangent of 30 over 2. Because 30 over 2 is the same thing as 15. I can use a half angle identity. There are a few half angle identities for tangent, but to me, the easiest one is tangent of theta over 2 equals 1 minus cosine of theta over sine of theta. I'm going to plug in my 30 for theta, so I have C equals 1 minus cosine of 30 over sine of 30, and I'm going to simplify. Cosine of 30 degrees is square root of 3 over 2. Sine of 30 is a half. We can get a common denominator. We can subtract on the top. We've got C equals 2 minus the square root of 3 over 2 divided by a half. When we keep change flip, we've got 2 minus square root of 3 over 2 times 2 over 1. And when those things, yes, C is equal to 2 minus the square root of 3. That was not a crazy problem, was it? Let's take a look at another problem that might look crazier than it actually is. Here we go. It says utility pole. 2 wires support a utility pole and form angles of alpha and beta, or A and B, with the ground. Find the value of sine of A minus B if tangent of A is 4/3 on the interval from 0 to 90 degrees and cotangent of B is 5 over 12 on the interval from 0 to 90 degrees. So again, it's giving us a ton of information, more information than what we probably want. But again, we got to take a second. We got to realize what's going on here. It's not, it's not the end of the world. We've got to try to see if we can understand stuff. Now, the thing that I think will help us a lot is understanding what's going on here. We have a utility pole that happens to be a big part of this problem. And with this utility pole, there are two wires going to the ground. Two wires going to the ground are forming two different angles. One of them is alpha, one of them is beta, one of them is A, one of them is B. We don't really know which one's the greater angle, so it doesn't really matter where we place them. And as we can see, when we draw it like this, we really have two triangles. We've got this larger triangle here, which I'm letting have the angle A as a base angle. And this would be a right triangle, of course, because the utility pole is standing straight up. We also have this triangle right here, which is B. And when we start to see these as triangles, well, tangent of A is 4/3. Tangent is opposite over adjacent. Cotangent of B is 5/12. Cotangent is adjacent.
Haley D4, you arrived in the office when you're finished. Haley D4, I need Armand Atala, Will Trotter, Manny and Kate Williams, Gage Garnto. Carson Fox is on her way. I'm ready for Camden Fountain and Katina Gore.
And if we want to find sine of A minus B, we have to use an identity. Wow, an identity. Sine of A minus B, that is a difference identity. Sine of something minus something else. We can split that up. Our difference identity for sine is sine of A cosine of B minus cosine of A times sine of B. Now I'm not going to work this one the rest of the way out because I think we can handle it. We find the sine of A, the cosine of B. The cosine of A, the sine of B, we plug those in, we simplify it, and then we get our answer. And that's what we want to do. And we take a look at these, these problems that seem challenging, they seem crazy. We just have to take a step back. We don't want to freak out. We don't want to, make things worse than they actually are. And we want to realize, what have we talked about? What have we learned? What do we have? What identities could help us out in the situation? If it seems to be getting more confusing and seems to be getting worse, then maybe we want to start over and retry. But we want to have some perseverance on these kind of problems, and we can make sense of it.